In this video, we are going to be solving rational equations that simplify to linear equations. And in these examples, we're going to be having like binomial denominators. Okay, so anytime you see an equation where you have like binomial denominators, if I were you, I would try and combine them into one fraction. Okay, so here we have 2y over y minus 5 minus 5 over y minus 5, and that's all equal to 7. So the first thing I would do, like I said, is combine this into one fraction. Since they have the same denominator, we don't have to do much. We can just rewrite it as 2y minus 5 over y minus 5, and that's equal to 7. And again, the reason we can do this is because they have the same denominator. If they didn't have the same denominator, this would be a little more complicated. Not impossible, but more complicated. So now to go ahead and clear out our denominator here, let's multiply both sides of the equation by y minus 5. Okay, on the left-hand side here, we'll have y minus 5 will cancel. And now we're left with 2y minus 5 is equal to 7 times y minus 5. Now, we should distribute this 7 here, and we'll get 2y minus 5 is equal to 7y minus 35. All right, so to solve this, let's go ahead and bring this 2y to the other side. And we'll go ahead and bring this 35 to the left-hand side. All right, so these two y's will cancel, and this negative 35 will cancel. And now we're left with negative 5 plus 35. So we have 30 is equal to 7 minus 2y. That's equal to 5y. So now we can divide both sides of our equation by 5. The 5's here will cancel, and we're left with y is equal to 30 divided by 5, or just 6. So y should be equal to 6. Let's go ahead and check that this works. Check our answer. We plug it in. So we have 2 times 6 over 6 minus 5 minus 5 over 6 minus 5. And this is really just 12 over 1 minus 5 over 1, which is just 7. Because you can really just think of this as 12 minus 5, which is 7, but that's what this was equal to in the first place. So we know that y equals 6 is the correct answer. Okay, let's take a look at an interesting example here. Here we have w over w minus 3 is equal to 3 over, we have w over w minus 3 minus 3 over w minus 3. Sorry, hold on just a second. That's going to be equal to 5. Okay. So here, what we should do is we could go ahead and combine this in one fraction. Okay, so here we have w minus 3 over w minus 3 is equal to 5. Okay, so what you'll notice now is that these actually cancel on the left-hand side here. Okay, so w minus 3 over w minus 3, these will cancel out, and we'll end up with 1 is equal to 5. We get that because anything divided by itself is 1. So if you have w minus 3 divided by w minus 3, we get 1 is equal to 5, which that is the technical term here, nonsense. So that must mean we have no solution. That's our answer here. Okay. So one other thing that I want to talk about here, this is very important here when dealing with rational equations. One of the things we have to check for are something called excluded solutions. Okay, before you even get started, it's oftentimes helpful to figure out what solutions cannot be possible, okay? So we now know what the answer is for number one. We know that it's y equals 6, and there's no real problems here. But one thing that we have to look at anytime you're dealing with rational equations, and that's where you have a variable in the denominator, you have to look at the denominator. So here we have y minus 5. One thing that if you remember back to previous math classes you've taken, we know that one of the biggest no-nos in math is to divide by 0, okay? So if we divide by 0, bad things happen, all right? And so we want to make sure that this denominator is never 0. So we need to say that y minus 5 cannot be equal to 0, okay? So to figure this out, let's actually just set y minus 5 equal to 0, add 5 to both sides, and we get y equals 5, okay? This is what we call an excluded solution. So let's say you had gone through all of this work and you'd ended up with y equals 5. You would know that that cannot be an actual solution here, okay? And sometimes that does happen. It'll show up with the excluded value, and you have to say, oh, because it's the excluded value, we can't really have a solution. And the reason for this is if you plug in y equals 5, while you're fine in the denominator here, okay, you're not, or in the numerator, you're not fine in the denominator, okay? Because if you plug 5 minus 5, you get 0, and you'd end up with 2 times 5, which is 10, divided by 0, and you can't do that. Or you'd end up with 5 divided by 0. You also can't do that. So we have to check for excluded solutions. That's probably something I should have mentioned before, but it hasn't popped up yet. Same thing here with this second example here. We have to check for excluded solutions here as well. So in this case, we know that w minus 3 cannot be equal to 0 because we can't divide by 0, okay? So to figure out what our excluded solutions are, we set w minus 3 equal to 0, solve for w, and we'll get w is equal to 3. So that is an excluded solution. And I know sometimes on the final, they like to ask for list all possible solutions, including excluded values. Sometimes they call them extraneous solutions. There are lots of examples. There's lots of different ways you can phrase this, but for now we're going to call this an excluded solution, or you can see this an excluded value. There's lots of ways you can describe it, but they all are kind of saying the same thing. So anytime you see a rational equation, it's usually a good habit to go ahead and check and see which values are actually excluded. Okay, so that'll do it for this video.